Hello, good day, or good morning. No morning. Good day. We are living in very interesting times. COVID-19, the virus is all over the place. It's in the news, it's everywhere. It's changed our lifestyle, and things are not, will never be the same again. So now we don't hug, we don't handshake, but one thing remains the same that we need to really, recognize that there are certain things that are beyond us as human beings, and we need to give glory to God for keeping us. In fact, because you can imagine Ghana. I don't want to go into the politics and everything. We don't have a lot of time. The little bandwidth I have, I want to make good use of it. So let's look at spatial database. Let's continue from where we left off, and I want to talk more about this. All right. So spatial databases, and we've talked a lot about systems and file and record systems. We talked a lot about database administration, the importance of that, why we need databases, how do we want to actually, create a database itself. Database management systems, the software does the job, and it's why special because we want to keep just what do you call it, special objects inside the geographical objects inside the database, something that never used to be the case. So it was weird for you to even think about uh, locations, within a database. I mean, but it's possible. Once you can keep XY data, that is really location. So, but then the most appropriate way to do it is to use spatial database systems. And we came to the point of even recognizing that relational database theorem is very important to know, even though the current trends are towards non-relational tables that have not been normalized and things like that. And so, of course, we understand the word normalization. We talked about that. And we said that if a table is normalized, then it should have gone through three or four steps or stages. And these are the first normal forms, second normal forms, third normal forms. And then we can even talk about the Boy's code normal form. Okay, so we have actually dealt with functional dependencies, which has helped us. We wanted to avoid update anomaly, deletion anomaly, and insertion anomaly. Are you okay? If I insert one record and it creates a certain problem, then I'll have to look at the table again. Okay, because maybe the table isn't good enough. And that is why we do normalization, to make sure that we break up our table and then on query they get joined up again. That's what we said in our previous lecture. So the boys called normal form was like the last one, and we said that most tables in third normal forms, which have actually obeyed, not allowed partial dependencies, okay, and avoided transitive dependencies, etc. And then of course the prime key being a super key. Okay, we have gone through all that, and so we should be having tables which are normalized. Are you okay? All right. So today we want to talk about relational algebra, and then we are coming to actually the last topic in the whole handout, and obviously we are looking at a tutorial. So let's see how it goes. I think probably our last meeting will be a tutorial on how to do something in PostgreSQL. So this is a very short lecture because relational algebra we're not going to go deep like that, but we're just going to touch on what it is. We need to appreciate what relational algebra is about. Okay, all right. So it's very important for us to recognize one thing, that the language being used to query a database. And you see, what is a database if you can't query it? Yeah, if you have a national database that you cannot find out, okay, who are you? And then we should be able to go into that database and then find out what the information concerning you. Say your name is Kojuman, we go and search in there, we don't find it there. That's a problem. If you say your name is Adasi or whatever, you need to look for it, search for it, and find it. Are you okay? Adasi is a good friend of mine. Okay, I'm sure you're wondering why I'm using that name, but obviously we need to find a way to query a database, and that is the structured query language. Are you okay? So query languages are very important. All right. So we do search through, we query databases, but we need to have behind our mind relational algebra. Why? Because we're trying to extract data, but it has to be in a very logical way. Are you okay? It has to be in a very logical way. And because tables have been broken down, or if you like relations into relations, yeah, databases, relations, yeah, that link is very important to recognize that. So we need to appreciate what relational algebra is. Relational algebra is a query language. Okay, so relational algebra is what a query language. All right, which takes instances of relations as input and yields instances of relations as output. Okay, so it uses operators to perform the queries. In other words, we are talking about algebra. Is really, what's algebra about? Ax equal to y, that is algebra. So relational algebra is saying that we need operations and we need some variables. What are the variables? Are going to be simply fields, if you like, columns in the table. And then we are talking about the operations being, if you like, the join and things like that, the selections that we are doing from the table. Are you okay? Because we want to find you in the table, a particular thing or object in the table, a tree in the table, a building in the table. Are you okay? Which particular one? The one with the lowest cost, things like that. This is what really happens in GIS, and behind it is this these theorems of databases. All right. So we can actually group the operators into two. We can have the unary or the binary. Are you okay? Operators is okay. So by is two, unit is one. Are you okay? So we can have operators that work on two parts, two things, and you can have one that works on one. All right. And we say that they accept relations as their inputs and yield relations as their output. As I was telling you, you need an operator, and an operator will take something like maths. If you do maths and you want to operate, okay, mathematical operations always require you to do what? To have two numbers and then you have the operator sitting in the middle. So 2 times 2, for example. All right. So the operator is the multiplication sign, and then we have the other parts of it. Are you okay? All right. As the inputs, what's the inputs? Maybe 2 and 3, and then the operator in the middle. This is the same concept. So here, what are our operators and operations that we want to take? Is that okay? All right. So we want to talk about the fundamental operations of relational algebra, and the fundamentals are as follows. We have the select operation, the project operation, the union operation, the set difference operation, the Cartesian product. You can even have the rename operation. All right. So these operations are used on relations. So what are you thinking about relations? I told you that when you think about relations, think about tables. Think about relations, think about tables, but think about tables when you have actually finished building and designing your database. And think about relations when you are in the process of a kind of concept, thinking about it in concept. There's no data in it, but a table exists. Are we okay? It's like the design. So relations are our inputs, and then the operators are this, for example, the select operator. So let's look at the select operator. So with the select operator, we have a symbol that we want to actually use, select operation. What do we mean by select operation? So if we have relations and we have a select operation, what does it do to the relation? It's like, think about if you have a table and you want to do a select, what does it do? All right. So what it does is very simple. I think we all know what it does. It selects. Select operation will select. It selects tuples. What are tuples? Think about tuples as rows. Okay, think about tuples as rows. So you select tuples that select the given predicate from a relation. So because I'm using Microsoft Word, let's look for synonym of a predicate. So we're looking at a base. Are you okay? The center. So a given predicate, but predicates are used really in grammar and English. You know, when you are being taught English and all that, the word subject and predicate, remember that? Okay, so here we have subject and predicate being used in database, you know, in the field of databases. So the notation is this, all right, that we want to actually select based on the predicate a certain relation. So please let me go over it again. We want to select a certain predicate based on a certain predicate, all right, a certain relation from a certain relation, all right. Select from a relation based on a certain what predicate, certain. What are we selecting? We are selecting tuples. What are we selecting? Tuples, and tuples are rows. Rows. So rows. Yeah. Let me spell rows for you. Oh, I thought I had my notepad here. So let me do a window capture and get my notepad showing here. Just hold on a second. I just want to type the word row so that you are not thinking about red roses, pink roses. Are you okay? White roses. Okay. So that's funny. Um, okay. This is asking me to create a test. You know. So I'm referring to rows. The word rows. Okay. This presentation is not going the way I wanted it. Okay, are you seeing something in there? Okay, so rose, the color, my color is, I need to choose a very nice color for this one. All right, so you can see this is what I'm, hey, where is it? Okay, uh, come on guys. I'm trying to just show you this thing is not working. Okay, let me do a window capture. Okay, so I'm referring to rows. Okay, so when we say tuples or mention the word tuples is synonymous with, we mean row, a row. Are you okay? In the table. So synonymous with it. Are you okay? It is synonymous. Okay, all right. So let's go back to our notes. Hey, what happened? My lecture is gone now. Okay, let's do another capture, screen capture here. The software I'm using is just so good. I love it. Okay, just love it. All right, so there we go. So this is it. Okay, the select operation. This is how it works. So let's do. I think we'll show an example, but let's look at it closely. So this symbol, what's it? How do you pronounce this symbol? Tor or something like that. So this symbol here, this is not Tor. It's looking more like it's a Greek symbol. I don't want to waste your time on it. We can go and look at it. It doesn't matter. Draw it to look just like that, and you'll be okay. This is not your Greek class. So that symbol that we are looking at, okay, stands for selection predicate. The selection predicate. And R stands for the relation. And P is a prepositional logic formula. Prepositional logic formula. which may use connectors like and, or, and not. Okay, so now those who have done computer programming before, remember that these are logical operators. Okay, so our selection predicate mm, combines with our prepositional logic formula. So what is the logic? I want to select something from here, but what's the logic? I want to select only I want to talk about girls today. It is a birthday of my sweetheart. Okay, let me talk about it. Anyway, so prepositional logic, yeah, is a P. R is a relation. Let's go. And then we are done. These terms may use relational operators like equal to, less than. So there's a whole lot that we can do. Okay, so for example, if you are dealing with integers, and want to find out, okay, all those who are having an average salary of or salary of let me see that bank account balance of 2,000. Okay, and that doesn't include me. Okay, so pay up for your handout. Okay, so we could be using these operators here, less than, greater than. Excuse me, throat is dry, got nothing to do with COVID, you're safe. All right, so we have an example here. If what I'm saying doesn't make sense, now let's look at it. We have a relation called books, and this relation called books, okay, we want to actually do a certain selection. This is the predicate. We want to get subjects, book with a certain subject. So everything here is the prepositional logic down here. Okay, let me get my highlighter. Everything down here is called the prepositional logic. In other words, is the logic of what do I want to select from books. So the table called books, the relation books. Why we not call it table? It's not populated. So now we have books. Are you okay? As a relation, all right? So it meets this formula here. Books are okay. Then we have positional logic P, select from. So more or less, this is actually saying select from books where subject is equal to database. So we want books which are actually on the subject database. So the librarian can quickly sit down and tell you that we have no books like that. Then you don't have to walk in there and then walk up and down the aisle for hours looking for something that doesn't exist. So this is how beautiful databases are. Guys, what do you think? This is just great. This is just great. It's good that we can do this. We can just query a database based on this. Are you okay? This logic. All right. So this is very simple, all right? But you can imagine the kind of relational algebra that we will write for extracting all students who have trailed a course. So that's going to be very interesting, isn't it? Yeah, that's going to be very interesting. So the prepositional logic then will have to make use of greater than. Are you okay? As we were saying up here, that we can actually introduce greater than and less than sign into our algebra. Okay. Algebra. X equal to A. Y equal to AX. Okay. Alright, but in this case, select and then relations. The relation here is books. So once you understand this, you understand the rest of it. So I think I should be ending the lecture. Okay. But let me just touch on a few things. The output selects tuples from books where subject is database. So now I would like you to ask questions. Is that okay? Do you understand this? And if you don't understand it, I'm pausing for just a few seconds. Let me just play a bit. You can ask questions as I talk. You make notes, and you can actually ask questions. Is that okay? All right. Um, no music is playing, is it? Or is it? Maybe it is. Maybe it's not. Okay. So if it's playing, that's nice. Okay, let me go back. Was only checking. Are you okay? All right. So any question, type it there. If you understand this, I like it when we understand just one little thing and then we apply it to many. It makes me so excited about. There's always hope. Are you okay? There's hope that you know. If the Bible says that there's hope of a tree that if it's cut, it can really come, grow again. I'm paraphrasing. All right. There's hope of a tree that if you cut it, it will grow up again. What we need to do is understand this one, and as we go, you understand the rest. Easy. So if you ask me questions, I will actually answer them for you. All right. So let your questions flow down there. In fact, I'm ready to answer your questions at any time. Okay. And remember that we will have to do a quiz of a sort. I mean, honestly, I need to give you some coursework to do. Very important. And your submissions will go on this page. Don't ask me questions on this. I'll talk about this again. For now, let's just go back to where we were. All right. And everything will be all right. Okay. Everything will be just easy peasy. Any question on the selection? Any question on the select operation? The select operation. Remember, we have about 5 more to go. But once you understand the select operation, I'll just run through the rest. Are you okay? All right. So we are selecting tuples from a relation that meets a certain prepositional logic. In other words, that meets a certain criteria. And the criteria is what we are calling the prepositional logic. Is that okay? All right. You're not asking me questions. Are you sure you're good? Any questions? Are we good? Are we good? I'm just waiting for you. Are you following it? Do you understand this? So we are learning a language. Remember that the topic today is relational algebra and SQL. So you don't say SQL, say SQL. SQL, structured query language. Are you okay? So we are looking at positional logic and relations, and the result is a set of tuples. Are you okay? Set of tuples. All right. So back to this. Let's carry on a bit. Okay. So we have examples here. We are saying that select from books where the subject of the book is database and the price is 350. Take note of and. That's logic. Are you okay? So positional logic. So this is it. Okay. Remember that end means that we want the both sides to be true. If the price is 450 and the subject is not database, we don't want that to be included in the result. So we are saying that we select tuples from the books where the subject is database and the price is 450. Strictly, if it were all, then obviously we have an issue, don't we? So in that case, then it means it will turn out to be true. Okay, so true, true, true or false, are you okay? Things like that. And that is where logic is very important. If you make a mistake, then your result is going to have, you're going to have problems with your result. Okay, select database, select from books where the database is at and the price is 450 or the year is greater than 210. So that one is interesting. So here we are using the greater than sign, etc. Okay, relational operator greater than over here. Okay, I think this is easy. All right. Let me actually add my PG admin and see. Okay, if we can actually do an example that works. Yeah. Right. So here, this is your interface. We'll be doing a tutorial, but I just don't want you to be margining things. So let's go to schema So remember, schema is a design. Okay, so the design contains a whole lot that I will talk about it later. But there is a table here called accounts. All right, and we want to perform a SQL query on it. It's okay, very, very simple. I don't know, like it doesn't get any easier than that. So a query, are you okay? You can see you want to do a query. All right, so it will go more like select star from accounts, and let me try this and see. Okay, so there you go. This is SQL for you. So I'm returning all these are the tuples. Okay, these are tuples. So these are like in the algebra, you don't mention values. You just say x, y. You don't talk about that. I won't be talking about these are all values. But in the algebraic term, we are talking about. Are you okay? All right. Even though it's fiddly, let me just try it because this particular database system, PostgreSQL, is actually funny sometimes when you are actually trying to look for something. So let's look for all users from the account whose usernames are called Fonzie. Okay, so let me try this and see if it works. Then obviously it will make me happy. Yes, obviously you can see this that I have only the user with username Fonzie. So this is the select query that I'm talking about. I'm very happy that it worked. It doesn't always work. All right, so project operation. What is project operation? That also uses tor or this Greek symbol again. I think these Greek symbols they are chasing us this morning, and they say that it projects columns that satisfy a given predicate. Is that okay? So notation is this. So we are projecting. In other words, we are actually selecting. Okay, in a way, it's like we are selecting. We are cutting only columns. Think about cutting bread or something. I always say when we say cut, we mean cut. Is that okay? So there we go. The projects A1, A2, A3 are attribute names of relation R. In other words, these are columns. All right. And then the relation is R. Simple. So select a few fields out of the lot. Is that all right? Okay. So let's look at an example. So when we say this project, this symbol means project. It means select from the books columns that are called or attributes that are called subjects and author. In other words, we could be talking about select from a parcel all fields that are known as rate and then maybe size. In other words, we are getting the rate and size columns only. Give me that and output that. It says it selects and projects columns named as subjects and author from the relation books. Okay, so there we go. We have the union operation, and you can imagine that it also works in the same way. Are you okay? All right. So the union operation works this way. It's just going to join. It's like it's going to put together. Are you all right? It says it performs binary union between two given operations. Binary means two. That means I don't come and try to put three. Are you okay? Binary means two. So English language for you. So we want to actually put together two relations. Are you okay? Two relations. One is called R, one is called U, such that the tuples within these belong to R or the tuples actually belong to S. So there should be, are you okay? So this is a whole statement here. Are you alright? That we can only unite it two tables if the tuples belong there to the appropriate. Are you okay? Notation RU. So where R and S are either database relations or relation result set. Are you okay? Could have been a result from, are you okay, that we want to now combine again. So I can do a select and then still bring another one together. So this is really a join. Are you okay? We do some kind of join. Now, RNS must have the same number of attributes. In other words, I can't put them together. It should be the same number of columns that I want it. Are you okay? Join them. Okay, great. Let's move on. Attribute domains must be compatible. Are you okay? Attribute domains should be compatible. All right. So, too much noise from my laptop. So, let me move away from it. Let me actually put it back where it's supposed to be. Let me mute it. I'm muting the sound. Okay, so here we are doing a union. Okay, now duplicate attributes are automatically eliminated. So this is really what we call a join. Okay, we are joining tables here. All right, we can do what we call the set difference. Obviously, set difference is the on the list that we have. I think it's the last one. We have the Cartesian product two coming in. So here we're finding the difference. You see, the result of a set difference is tuples which are present in one relation but are not in the second relation. We find all the tuples that are present in R but not in S. So here we can have the name of authors who have written books but not articles. So give me this one, authors. Also give me authors again, but make sure that you take out any authors, any records in which we have no that have no articles. Are you okay? So we are selecting authors from a relation books, selecting authors from relation articles. Are you okay? But we want to avoid certain authors. There could be a reason for that. Okay, so Cartesian product is also interesting. It combines which of two different relations into one. Obviously, that will not do what the set difference is doing. Okay, we just combine where RNS are relations and the output will be defined as RNS. Are you okay? All right. So interesting, isn't it? Let me actually go here as let's play with it again in Postgres. So select username from account. Let's see if that works. Okay, yeah, that works. So what is this one? So I want someone to type what this is. What I just did, I'm selecting a column from the table account. What is that called in relational algebra? What is that called? So you can type it in there and then you never fail this course. As I always say, right? Please follow what I'm talking about. Don't just put it on and do your own work somewhere. Are you okay? Some people are not even watching. I know, but I'll get you. All right. Not in that sense, but yeah, let's carry on. Okay, so this is what we are learning today. Relational algebra. This is what it's all about. Operations on relations based on predicates logic. Are you okay? All right. Let's move on. Output of the Cartesian product, as you said, is represented by that R. It's like R times X. It's a product, but it's a combination. Please, simple as that. So let's look at this one: books, articles. So select from books and articles where you can find that the author is called tutorials point, which means that you should have the author field in the two tables. Are you okay? So normally this would be some kind of common field in the two, and I think that's what we said. We can have the rename operation. It's not really binary, is it? Yeah, it doesn't combine two things. So the rename operation will definitely rename, right? The results of relational algebra are also relations, but without a name. So the rename operation allows us to rename the output relation. The rename operation is denoted with small Greek letter. Row. Of course, this one, not this one. So this is row. Yeah. Row, tall, etc. These are all the Greek symbols. Okay. So additionally, we can have set intersection, assignment, natural join, and all that. So these are all operations that are done. Okay, so the names imply what they do. Obviously, we're joining here, we are assigning, all right, we are intersecting. That means you find a common, if you like, records, okay, between the two relations. They are binary operations. So obviously, code, see, we're talking about the boy's code normal form. He spent time actually working on this. Okay, he defined the whole relational model thing. So he's really the father of relational algebra, if you like, because he came out with the theory. Okay, so a set of operators operated, we can do, the things that we do in algebra in this one. So if you're very good in algebra, you'll be very good at databases, the querying it and things like that. Because sometimes it's tricky. If someone cheated in exam, how do you find out that, okay, if someone is actually messing up your database, you may want to do a whole lot of queries that will help you to actually appreciate it. So yeah, so this is we are coming to the end of our short lecture, structured query language. I think we've mentioned that it's very important for you to know it. There's a whole lot of history about it that you need to actually know. It's okay. Learn it. In fact, spend it. I'm not going to force you to do this. In fact, your assignment is to make sure that your computers are ready for the next meeting. The next meeting is going to be a tutorial. So make sure your PostgreSQL is set. Okay? Make sure that your PostgreSQL is ready. The software is ready. Make sure that your QGIS is also ready. Is that okay? Don't wait, till the time. And then I don't want excuses. Okay, I don't want excuses. Make sure you remember all the things that we've learned in GIS, in cartography about it. All right, make sure you can connect to find out if your QGIS is talking to your PostgreSQL, which is what we are going to do. We are going to be interacting between PostgreSQL and make sure you can come to the database manager, find PostGIS, use your credentials to log in and to access the database. Are you okay? So you should be able to put in, say, that the username. Normally it is Postgres, normally, usually. So remember your password. Worst case, if it's not working, you see we are connected now. If it's not working, simply, now this is a table that we're working with. Make sure you don't have any errors whatsoever. Are you okay? As I'm having here. Okay. All right. Make sure you do have the right things going for you. Everything is working fine. Okay. Don't wait till last minute, like I said. Check once you can have the connection and you can see something like this. You are good for our next lecture. You are good for our next lecture. Okay. Okay. So please do what you've been asked to do. I don't want problems. This is a video. I can't stay for so long. It's fine. I will probably end here. Okay. All your questions can still come under Rita. I'll answer them as we go. And yeah, I don't know if there's something that I've left off. Let me look at the end of it. What do we have in here? Yes, understand that this is how the whole database works. Understand the architecture. Are you okay? This is what we call the architecture of SQL. Are you okay? Or SQL, when you query, this is what happens. Are you okay? There's a query language processor, there's database management engine. These are all software components that I'm not really like teaching you per se, but you need to know. If I ask you, you should be ready to answer. All right. And the statements, yeah, I think it's the last one I'll talk about. Then I'll say goodbye to you for this for today. SQL commands. These examples: select, You see, I used select this morning, isn't it? I could have used insert. I can do drop. Are you okay? Can do delete. Drop means a database. You are dropping the database. So the statements have been grouped into about three. We have the data management language. It's the same statements, but they are grouped into database management language. We have the data control language, okay, which actually makes use of grants. So privileges. When you use systems like Ubuntu and all these Unix systems, they actually, you meet these things a lot. But yes, in Windows too, we can grant a user a privilege. So not all users can go into your bank account and start changing your balance. Can you imagine if that was possible? Only one person is probably responsible. So we can write a statement that will make sure that the user, whoever can access, for example, we don't talk about the Postgres user. So we give them privileges. Are you okay? So we have the DML, the DCL. Are you okay? We have the data definition language. Is that okay? All right. And so data definition create. So if you want to create a table, create table. Are you okay? Then you just touch on which table you want to create. I mean, I think we'll be playing with this when we meet the next time online. Are you okay? Create table, table one. Let's see if this works. Sometimes capitalization is an issue. Are you okay? In these ones, that should have worked. Okay, create table, table one, and it's saying what syntax near this. Okay, so it doesn't want it. Okay, it means that there's a problem with this. Maybe it doesn't want a capital letter in front, so let's keep it small letter. I think so. Yes, so every system, yeah, the nuances, let me put it that way. Even then, he still finds it. Okay, let's take the one away and let's see. Okay, we still have an issue, but yes, we will have to find a better way of doing it so that we don't have a problem. Let's call this bank. Okay. Okay, so you see that definitely we're gonna have issues. Are you okay? As you go, but of course I'll do my homework before we come. Create table bank. That isn't working, but yes, that is why we are doing the tutorial. I wish that had worked. Then we could uh, carry on with it, but it's okay. We'll handle all that next week. We create tables. We try to put in some special stuffs and make it more interesting. So dedicate that lecture. Dedicate the next week's lecture to that. So take care of yourself. Wash your hand always, and stay safe. Don't try to be macho. Yeah, just keep yourself clean. Stay at home. I think that is what we are saying to everyone now. Yeah, stay at home. We are being told. Everyone is being told to stay at home. Hello. Good morning. Don't